Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Welcome to Episode 2 of Multi-Region Platform Engineering. Today, we're diving into production patterns, what companies actually build, not what they claim in conference talks. Before we start, let's do a quick recall from last time. Pause for a moment and try to remember. What are the three vertices of the CCC triangle? What was the real cost multiplier for multi-region? Not the marketing number, the actual one. And when does single region beat multi-region? Take 5 seconds. Think about it. All right, the CCC triangle. Cost, complexity, capability. You can optimize for 2 vertices, never all 3. The cost multiplier? 7.5 times for complex setups, not the 2x AWS claims. In single region wins, for most companies under 10 million in revenue, the downtime math simply doesn't justify the spend. Now here's why that matters today. That CCC triangle, you're about to see it applied to real production patterns. Every company I've worked with sits somewhere on that triangle, and their multi-region pattern should match their position. But often, it doesn't. Netflix runs active everywhere. Your startup probably shouldn't. By the end of this lesson, you'll know exactly which pattern fits your actual needs, not your aspirational architecture. Here's what you'll learn. First, the 4 multi-region patterns and their actual RTO and RPO numbers, not the theoretical ones from vendor documentation, the measured numbers from production failures. Second, how to calculate which pattern your business actually needs based on downtime cost and complexity tolerance. Third, why 62% of enterprises choose hot-warm, and why that's probably the right choice for you too. And fourth, how to map your organization on the CCC triangle and select the matching pattern. Let's start with the patterns themselves. You've got 4 fundamental options. Think of them as points along a spectrum, from cheapest and simplest to most capable and complex. Cold standby sits at one end. Your infrastructure is pre-configured but not running. Data gets backed up to a second region. Think of it like a spare tire in your trunk. It's there if you need it, but you have to stop and install it. RTO, 4 to 8 hours. RPO, 12 to 24 hours of data loss. Cost, 1.5 times your single region bill. Next up, hot-cold. Infrastructure is running in your secondary region, but it's receiving 0 traffic. Data replicates continuously. This is like having a backup generator. When power fails, it kicks in. RTO, 15 minutes to 2 hours. RPO, 1 to 5 minutes of data loss. Cost, 2.5 times single region. Then you've got hot-warm. Infrastructure running in both regions, but your primary handles most traffic. The secondary serves read traffic or handles overflow. Picture 2 data centers where one is primary but the other can take over. RTO, 30 seconds to 5 minutes. RPO, less than 1 minute of data loss. Cost, 3.5 times single region. And finally, hot, active. Both regions handling production traffic simultaneously. Full write capability in both locations. 2 completely independent data centers running in parallel. RTO, subsecond to 30 seconds. RPO, near 0 data loss. Cost, 7.5 times single region. Notice something? Cost scales non-linearly with capability. You're not just paying for double the infrastructure. You're paying for data synchronization, conflict resolution, operational complexity, engineering time. These aren't arbitrary categories. They represent real engineering trade-offs that map directly to the CCC triangle. Each step up in capability requires exponential increases in cost and complexity. Now let's talk about why Hotworm dominates. 62% of enterprises run Hotworm. Not because it's the most capable. Because it's the sweet spot on the CCC triangle. Let me show you exactly why with a real example. Picture an e-commerce platform, $50 million in annual revenue. 100,000 daily active users. Average order value, $85. 3% conversion rate during peak hours. Here's their reality during Black Friday. They're processing $200,000 per hour. That's their real downtime cost. Not 50 million divided by 8,760 hours in a year. The actual peak revenue at risk. 4 hours of downtime during peak season? $800,000 in lost revenue. Plus the customer trust damage. That's their real exposure. They run Hotworm between US East 1 and US West 2. Primary region handles 95% of write traffic. Full production workload. Aurora global database with the primary writer there. Secondary region handles read traffic, product catalog, search results. Writes get redirected to the primary. Aurora global database has a read replica with 1 second lag. EKS cluster running at 20% capacity, ready to scale. Now watch what happens when US East 1 goes down at 2 p.m. on Black Friday. Minute 0. Primary region fails. Alarms fire immediately. Minute 1. On-call engineer confirms the outage, initiates the failover runbook. Minute 2. Route 53 health checks fail. DNS starts shifting to US West 2. Minute 3. Aurora Global Database promotes US West 2 to writer. This takes 90 seconds. Minute 4. EKS cluster autoscales from 20% to 100% capacity. Minute 5. Traffic fully shifted. System operational. Total RTO, 5 minutes. RPO, 45 seconds of data loss from replication lag at the moment of failure. Revenue lost, $200,000 per hour divided by 12, $16,666. Now here's the cost-benefit math. Hotworm costs them an extra $15,000 per month versus single region. That's $180,000 per year. One major outage pays for 4 years of Hotworm. The math works. But why not hot? Why not go all the way? Hot would cost them an extra $40,000 per month. $480,000 per year? For what benefit? RTO drops from 5 minutes to 30 seconds. That saves them $1,400 in lost revenue during an outage. You're paying $480,000 per year to save $1,400 during an outage. That math absolutely does not work. This is why 62% choose Hotworm. It's the engineering sweet spot. Real resilience without irrational costs. You accept 5 minutes of downtime to avoid the 7.5 times cost multiplier. Now let's talk about the Netflix myth. Netflix runs active, multi-region. Every conference talk references it. Every architecture blog post holds it up as the ideal. Here's what they don't tell you. Netflix's business model makes hot rational. Their revenue model is subscription-based, not transaction-based. $6.5 billion per quarter. $26 billion annually. Every minute of downtime costs approximately $50,000 globally in customer experience damage, potential churn, brand impact. 1 hour of global Netflix outage. $3 million. Netflix spends approximately $200 million per year on AWS. If hot costs an extra $100 million over single region, they need to prevent 33 hours of outage per year to break even. At their scale, with 260 million subscribers, that math works. Your $50 million SaaS company? 1 hour of downtime costs maybe $10,000. If you spend an extra $300,000 per year on hot, you need to prevent 30 hours of downtime annually to break even. Single region, with good practices, has maybe 2 to 4 hours of downtime per year. Hotworm reduces that to essentially 0. You don't have 30 hours of downtime to prevent. The ROI doesn't exist. And here's what Netflix actually built to make hot work. A full chaos engineering team. 25 plus engineers. Custom service mesh, not off-the-shelf Istio. Region-independent routing with thousands of hours invested. Multi-region data stores, custom built on Cassandra. Years of operational experience. They started this in 2011. You don't have the engineering resources Netflix has. Even if you did, you don't have their revenue model to justify it. Netflix demonstrates what's possible at hyperscale with unlimited engineering resources. It doesn't demonstrate what's rational for most companies. Learn from their technical innovations. Don't copy their pattern unless your business model matches theirs. Let's look at the simpler patterns. Hot-cold is hot-warm's cheaper cousin. Infrastructure running in both regions, but your secondary receives zero traffic until failover. When does this make sense? Revenue under $20 million annually. You can tolerate 15 to 30-minute RTO. You want insurance without operational complexity. You don't need active data consistency. Real example. B2B SaaS company with 15 million in revenue, 500 enterprise customers. Most usage happens during business hours, 9 a.m. to 6 p.m. Eastern. They can notify customers of a brief maintenance window if needed. Acceptable RTO, 30 minutes. Hot-cold costs them 2.5 times single region. Gives them disaster recovery without the complexity of routing real traffic to multiple regions. Extra $8,000 per month. One major outage every 3 to 4 years justifies it. Cold standby is disaster recovery, not high availability. When do you use this? Regulatory requirement for geographic backup. You can tolerate 4 to 8 hour RTO. You want to recover from catastrophic region failure. You don't need fast failover. Healthcare data platform. HIPAA requires data backup in a geographically separate location. RTO acceptable 8 hours because it's a batch processing workload. RPO acceptable 24 hours with daily backups. They snapshot data to S3, replicate to a second region. Infrastructure as code ready to deploy if needed. Cost 1.5 times single region. Meets compliance without over-engineering. Now let's build your decision framework. Step 1. Calculate your downtime cost. Revenue per hour during peak times. Not average revenue. Peak. If you're B2B SaaS, multiply by the business impact cost. Lost customer trust. Emergency support costs. Potential churn. That's your real downtime cost per hour. Step 2. Determine acceptable RTO. Be honest. Not aspirational. Actual. Can you tolerate 4 to 8 hours? Cold standby. 30 minutes. Hot-cold. 5 minutes. Hot-warm. 30 seconds. Hot-hot. Most companies think they need 30 seconds. They can actually tolerate 5 minutes. Step 3. Calculate pattern cost delta. Take your current AWS bill. Multiply by the pattern multiplier. Cold standby, 1.5x. Hot-cold, 2.5x. Hot-warm, 3.5x. Hot-hot, 7.5x. That's your annual premium. Step 4, break-even analysis. Annual premium divided by downtime cost per hour equals break-even hours. If you need to prevent more downtime than you realistically have, the pattern is over-engineered. Here's an example. Current bill. $10,000 per month equals $120,000 per year. Downtime cost, $5,000 per hour. Hot-warm premium, 3.5x minus 1x equals 2.5x increase. That's $300,000 per year extra. Break-even, $300,000 divided by $5,000 equals 60 hours of downtime prevention needed. But typical single-region downtime is 2 to 4 hours per year. Hot-warm is over-engineered for this scenario. Hot-cold at 2.5 times, 180,000 extra per year, 36-hour break-even is closer to rational. Let's talk about common mistakes. Mistake 1. Copying big tech without big tech revenue. You read Netflix's architecture blog. You implement active. Your revenue doesn't justify it. You've spent 18 months building something that protects against downtime you don't actually experience. Fix. Calculate your downtime cost and work backwards to the appropriate pattern. Mistake 2. Confusing RTO requirements with actual needs. Your executive team says zero downtime. They mean highly available. 5 minutes of RTO is effectively zero downtime for most businesses. Users refresh the page. They come back. They complain less than you think. Fix. Show them the cost of each additional 9 of availability. 300,000 extra for 99.99% versus 99.95% is a 30-minute difference annually. Mistake 3. Not testing failover. You built hot-warm. You've never actually failed over. When US East 1 goes down for real, your runbook doesn't work. Your RTO is hours, not minutes. Fix. Quarterly failover drills. Actually promote the secondary to primary. Discover what breaks. Fix it before production forces you to. Time for active recall. Pause and answer without looking back. Question 1. What are the 4 multi-region patterns and their typical RTO ranges? Question 2. Why do 62% of enterprises choose hot-warm instead of hot-hot? Question 3. Using the decision framework, if your company has $20 million in revenue, downtime costs $8,000 per hour during peak, and your AWS bill is $8,000 per month, which pattern makes sense? Take 5 seconds. Think through the answers. Here they are. Question 1. Cold standby with 4 to 8 hour RTO. Hot-cold with 15-minute to 2-hour RTO. Hot-warm with 30-second to 5-minute RTO. Hot-hot with subsecond to 30-second RTO. Question 2. Hot-warm hits the sweet spot on the CCC triangle. It provides real resilience with a 5-minute RTO at 3.5 times cost instead of 7.5 times, without the operational complexity of active-active data synchronization. Question 3. Hot-warm annual premium, 8,000 times 12 times 2.5 equals 240,000 per year extra. Break even, 240,000 divided by 8,000 equals 30 hours. That's over-engineered. Hot-cold at 1.5 times extra, 144,000 per year, 18-hour break-even, is more rational unless regulatory requirements demand faster recovery. Let's recap what we covered. First, 4 patterns exist on the CCC triangle spectrum. Cold standby at 1.5 times cost with a 4 to 8 hour RTO. Hot-cold at 2.5 times with a 30-minute RTO. Hot-warm at 3.5 times with a 5-minute RTO. And hot-hot at 7.5 times with a 30-second RTO. Second, hot-warm dominates with 62% adoption because the math works. It provides real resilience without irrational cost. 5 minutes of RTO is acceptable for most businesses. Third, Netflix's architecture is rational for Netflix, not for you. Their revenue scale and subscription model justifies hot-hot. Your transaction-based revenue probably doesn't. Fourth, a decision framework beats cargo cult architecture. Calculate your actual downtime cost. Determine honest RTO needs. Compute break-even hours. Pick the pattern where the math works. Fifth, most companies over-engineer by 2 to 3 times. They build for aspirational requirements instead of actual business needs. That's how you waste $200,000 to $500,000 annually. Remember back in episode 1? I said you can optimize for 2 vertices of the CCC triangle, never all 3. Hot-warm optimizes for capability and acceptable cost while keeping complexity manageable. Hot-hot optimizes for maximum capability, accepting high cost and high complexity. Hot-cold optimizes for low cost and low complexity, accepting limited capability. Every pattern choice is a position on that triangle. Choose consciously. Next time, we're diving into episode 3, the Data Layer Foundation Aurora Global Database Deep Dive. You'll learn how Aurora Global Database actually works under the hood. The 6-way replication nobody explains. Why physical replication beats logical replication for multi-region. The 45 to 85 millisecond replication lag reality. And how to handle split-brain scenarios when regions diverge. This is where we go from patterns to building blocks. Aurora Global Database is the foundation of most hot-warm and hot-hot architectures. You need to understand exactly what it can do and where it breaks. See you in the next lesson.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.